The Earth is rich and varied in its complexity. It is unique in its narrow range of temperatures, its sustaining atmosphere, and its circulating oceans. It supports life, and everywhere creatures have evolved to take advantage of the abundance provided by our planet. The Earth is roughly 4.5 billion years old, and life started to emerge after the first billion years. Since our planet's birth, energy levels from the Sun have increased, yet the Earth's temperature has only fluctuated in a very narrow band. Our planet's atmosphere has a high proportion of one of the most reactive elements, oxygen. It is the product of green plants, and it is essential for all animal life. The tropical rainforests are the great replenishers of oxygen in the atmosphere. These forests are areas of great diversity, with birds, reptiles and mammals not just living from the plants, but contributing by dispersing seeds and recycling nutrients. These vast forests are made of complex carbon compounds, gained by extracting carbon dioxide from the air and water from the ground. The process converts light energy into chemical energy, liberating oxygen. Everything depends on energy from the sun, and in equatorial regions, where the sun's rays are more intense, life thrives. The open grasslands of Kenya and Tanzania support giant herds of grazing animals, like the wildebeest and the zebra, along with smaller numbers of predators. The wildebeest and zebras follow an annual migratory route that is dictated by the rains that trigger fresh growth in the grasses that they feed on. When conditions are good, wildebeest numbers can exceed the 1 million mark, with the zebra population around 500,000. Elephants too rely on plentiful vegetation, and they are also attracted to the plains after the mid-year rains have spurred new plant growth. Elephants are the largest land-dwelling animals, with adult males weighing more than 6 tons. Such a creature needs more than 130 kilograms of food every day. Elephants are important to the survival of the forest and savanna. Many of the plant species that the elephants eat can only germinate after passing through the animal's digestive tract. And new growth is promoted as the elephant breaks down older trees. As the wildebeest's migrations are tied to weather, predators that rely on the wildebeest are tied to the patterns of the moving herds. The grasslands that support these huge herds form 1/5 of the Earth's vegetation cover. All of the grain crops important to humanity are types of grass, yet grasses have emerged only recently in our planet's history, and the grazing animals that feed on them have evolved in parallel. While the tropical grasslands support a rich variety of life, these areas are still only a portion of the planet's surface. Most of the Earth is covered by ocean, and here too life is abundant. Just as on land, animal life in the sea depends on oxygen. But here, the plants that produce most of the oxygen are phytoplankton, single-celled, free-floating plankton that live near the ocean surface where sunlight easily penetrates. The web of life in the marine environment is richly diverse, with everything depending on the microscopic plant life, which in turn depends on nutrients replenished by upwellings from the ocean depths. The level of salinity in the world's oceans is around 3.4%, though there are small regional variations near ice packs, river mouths, and shallow equatorial waters. Life in the ocean is adapted to this very narrow band of salinity levels, and the geological record shows that these levels have remained constant for a very long time. Science is not certain why this should be so, as rivers continue to bring more salts to the seas. Speculation grows that life itself could be a regulating factor. There are some aspects of our planet that protect life in ways we've only recently understood. The Earth is geologically active. Beneath its solid outer crust, a mantle of molten magma circulates. In certain weak areas, this molten material is able to force its way to the surface as volcanic activity. The deep movement of magma generates the Earth's magnetic field that makes compass needles point north. The interaction of this magnetic field with material from the Sun was unknown. The Sun emits a stream of charged particles known as the solar wind. Comprised mostly of high-energy electrons and protons, this solar wind can become extreme at times of peak solar activity, and it is the Earth's magnetic field that protects our planet from the worst effects of this solar bombardment. At times of extreme solar activity, some of these particles are able to spiral into the Earth's atmosphere near the poles. They interact with the ionosphere, resulting in the phenomena we know as the auroras. The oceans play an important role in regulating the Earth's climate. The frigid polar regions provide the driving force for the ocean currents that redistribute heat across the planet. The extremely cold waters are able to hold much higher levels of dissolved oxygen than the warm equatorial seas. This means life in the polar oceans is abundant. Huge breeding colonies of penguins depend on the ocean for survival. Breeding colonies of these macaroni penguins can exceed 1 million pairs. On their small islands they have no predators, but in the sea, leopard seals and killer whales wait near the colonies for penguins going to feed. The penguins have a diverse diet of fish, squid and crustaceans, but mostly they eat the tiny krill that swarm in dense clouds in the Antarctic waters. The krill eat the phytoplankton. They are protected from the cold by their fine feathers and a thick layer of fat. The albatross also depends on the ocean, diving for fish, squid and krill. The Ross Sea is home to a large proportion of Antarctica's most numerous penguin, the Adelie. These birds' foraging range is governed by the extent of the ice pack, and their breeding cycle is linked to the brief Antarctic summer, and they are also prey for many of the seal species in these waters. The only creature that stays in Antarctica for the winter is the emperor penguin. They make breeding colonies of around 1,000 pairs on stable pack ice, usually near cliffs, for protection from the wind. After the male has incubated the egg during the winter, the female returns, and the pair take it in turns to visit the ocean on foraging trips, bringing back extra food for their growing chick. Most of the world's fresh water is locked away as ice in Antarctica. At the north, there is no polar continent, but nearby Greenland fills a similar function. Northern polar wildlife is also abundant, though it differs greatly from that found in the south, but it is still dependent on the bounty of the oxygen-rich ocean for food. These cold polar waters sink to the ocean bottom, drawing in water from lower latitudes. It is this temperature difference that drives the ocean currents. Without the warm Gulf Stream current in the Atlantic, Europe would freeze over. The warmer surface layer interacts with the atmosphere, losing water through evaporation and slightly increasing the salinity level, which will help it sink again when it reaches the frigid zone. As the deep ocean currents well up to the surface, they carry with them high levels of nutrient that nourishes the phytoplankton upon which marine life depends. The great whales live directly off the krill that feed on the phytoplankton. During a single day, a large whale will consume more than 3,500 kilos of krill in a short food chain that links single-celled plants with the largest animal that has ever existed. In the tropics, shallow waters can be very productive, where different types of phytoplankton support the food chain. However, areas such as the West and Central Pacific are largely marine deserts because ocean circulation does not occur there, and nutrient levels are virtually non-existent. The most diverse and abundant types of marine life are the microorganisms. A litre of seawater can hold as many as 1 billion microbes, and very little is known about their role in the marine ecosystem. Tropical coral reefs form the basis of another rich marine ecosystem, where a complex relationship exists between the reef-building polyps and the small, oxygen-producing algae known as zooxanthellae. We are only just starting to understand the complex nature of the global ocean system. But some factors seem to be changing very rapidly. We know that polar ice is diminishing, affecting seawater salinity. Climatologists say that this could slow the ocean currents, and some polar species are already suffering from the reductions in ice. And it has recently been discovered that oxygen levels in the deep ocean are falling. What's causing this is not understood. Levels of dissolved CO2 in the ocean are rising, and the consequences of this are also unknown. Water circulates in the Earth's atmosphere as well, and this is driven by high levels of evaporation in equatorial regions. The tropical Western Pacific has sea surface temperatures of around 28 degrees Celsius, the warmest in the world. These warm waters pump an enormous amount of moisture into the atmosphere, an important factor for the global climate system. The tropics are where most of the energy enters the planet, and the polar regions are where most of the energy is lost. Clouds have an intricate relationship to the Earth's average temperature. Between the cloud and the Earth's surface, heat tends to be locked in. Yet the white upper side of the clouds reflect much of the sun's radiant energy back out into space. Above warm seawater, huge tropical storms can form. If conditions are right, these storms can build into cyclones or hurricanes, capable of immense damage. If more heat gets trapped by the changing nature of the atmosphere, average storm intensity will increase. A different type of storm can develop when air connected to a cumulonimbus cloud begins to rotate at high speed, extending a funnel to the ground. Tornadoes are common in the central plains of North America. Clouds will also form above tropical forests, fed by water vapour transpired from the leaves, at the same time releasing oxygen and fixing carbon. All green plants on land and phytoplankton and cyanobacteria in the oceans maintain atmospheric oxygen. But this process is very complicated, and there are still many aspects of the oxygen cycle that we do not understand. Mountains play an important role in the Earth's hydrological cycle. High peaks are cold because the sun's radiant energy is not converted to warmth until it strikes solid ground. This means the atmosphere is heated from the bottom up. Clouds are forced to precipitate as winds rise above high mountains. Because of the high altitude, this precipitation will often fall as snow, and mountain ranges act as water storage areas. Many mountains maintain such a large snowpack that ice forms, and glaciers become an even greater means of storing water. Across extensive mountain ranges, huge amounts of water in the form of snow and ice remain fixed during the cooler months to be released gradually over the warm season. Most of the world's great river systems have their source in mountains where they are constantly fed by the thawing snow and ice, which is replenished every year. Rivers like the Ganges, the Yangtze, and the Rhine all originate from small mountain streams. Small rivulets join with other streams to form ever-expanding flows. Rivers fed by melting ice and snow have a more constant, reliable flow than rivers formed as part of a drainage basin, fed by more intermittent rains, a factor very important to the agricultural lands that they cross. Further along the path of the mountain stream, it continues to grow till it flows with speed and power on a journey that would take it to the sea. Over geological timescales, rivers can carve great valleys. rock is worn down into fine silt that nourishes the land further downstream. Rivers form only a tiny proportion of the world's fresh water, but all terrestrial life depends on rivers and lakes for the water that they need to survive. Across the Earth, rivers water the rice paddies and the wheat fields that provide our world with its two most common staple foods. This constant cycle, from sea to cloud to river and back to the sea, continues to keep the Earth habitable. There are some parts of our planet that humanity is trying to preserve in a pristine state. We are just beginning to realise the importance of biodiversity in maintaining healthy ecosystems, and World Heritage Sites are an attempt to preserve natural systems without human interference. The Norwegian coastline has more fjords than that of any other country. Southwestern Norway has 2 fjords that are among the world's longest and deepest, and they have been listed for protection. Their precipitous rock walls rise 1,400 metres from the Norwegian Sea. These areas are not just preserved because of their beauty, they serve as a living record of how the local environs were before the pressures of population eroded the natural ecosystem. In South Africa, Vredefort Dome is a 2 billion-year-old impact crater with a radius of 190 kilometres. In the western Egyptian desert, fossils represent one of the major stories of evolution, the emergence of the whale as an ocean-going mammal from a previously land-based animal. The fossils of Al-Hitan show the youngest archaeocets in the last stages of losing their hind limbs. Almost all major oceanographic processes occurring in the planet's oceans are present in the Gulf of California, in northeastern Mexico. The marine reserve features 695 vascular plant species and an abundance of bird life. The Sea of Cortez and its islands are regularly visited by more than 1/3 of the world's marine mammals. The site is home to 891 fish species, 90 of them endemic to the Gulf of California. In Australia, wildlife corridors are being cultivated to allow birds and animals to travel between isolated areas of wilderness. In the populous southeastern part of the country, more than 50 species are threatened. The 2,800-kilometre climate spine, approved by state and national governments, will link the country's entire east coast, from the snow-capped Australian Alps in the south to the tropical north. The World Wildlife Fund has revealed that from 1970 to 2000, populations of terrestrial and marine species dropped by 30%, while freshwater populations went down by 50%. Human demand for food, fibre, energy and water is depriving wildlife of the environments they need for survival. Since 1961, on average, each human has increased its demand on the Earth's resources by a factor of more than 2. Current consumption is estimated at being 20% above the capacity that the planet can sustain. Over the past 100 years, the world has seen unprecedented levels of species extinction. Preservation of biodiversity is not just a sentimental or aesthetic concern. Humanity has evolved as part of the community of life, and we cannot survive without the stabilising effect delivered by this web of life. It is unclear how long the current levels of human consumption can continue before the planet is incapable of supporting the diversity of life we are familiar with. Iconic species like the panda and the tiger are at dangerously low population levels, primarily because human population levels are so great. Some ecologists are starting to view the Earth and all its life forms as a single system that works to preserve the conditions favourable to life. Analysis of the geological record reveals that oxygen levels in the atmosphere, salinity in the oceans, and average planetary temperatures have remained remarkably constant, though it is not immediately clear why this should be so. Research suggests that the broader the spread of interlinked life forms, the more stability the whole ecosystem maintains. Already, damage to parts of the ecosystem are affecting human populations. Africa has a special place in our planet's history. It is here that humans first emerged, and it is here that small populations are still trying to live in harmony with the environment. The San people of southern Africa still attempt to follow a traditional life, using an extensive knowledge of their Kalahari homelands to survive in harsh conditions. Archaeological evidence shows these people have been living in the region for 10 to 20,000 years, though around 1,000 years ago they were pushed to the more extreme areas of the Kalahari by the dominant Bantu tribes. Each San uses around 1/20th of the resources that the average world citizen does. Africa is special in other ways. Modern man spread across the world from Africa, settling in new territories and exploiting new species. The fossil record shows that on other continents, soon after contact with humans, the macrofauna, the large animals, became extinct, possibly because they were so easy to hunt. In Africa, the large animals evolved alongside humans and adapted to survival with the aggressive hunters. Our planet Earth is a rich and beautiful place with specially adapted creatures living in almost every niche. As far as we know, it is the only place where life exists.